Okay, Sid, in this question, we have, here's a polyatomic ion right here. Polyatomic ions are those groups of elements that travel together and have a charge, and they're on table E. So you can go ahead and look at your reference table and look at table E. Let me erase this, and let me show you how we would tackle this. All right, because this carbon, this CO3 does not show up on both sides of the equation. Here you have a CO2, but you don't have a CO3. You're going to want to break that apart. So I'm going to make a list H, Cl, K, C, and O. And on this side, I'm going to repeat this list. You can't see what I'm pointing to. I'm going to take this list and I'm going to repeat it on the other side. H, Cl, K, C, and O, keeping them in the same order. So it's easier to compare what you have on the left side of the arrow. Right, there's my arrow right there. What you have on the left side and what you have on the right side. All right, so let's count. We got one H, we got one Cl, we got two potassiums, we got one carbon, and we've got 3 oxygens on the reactant side. On the product side, we got 2 hydrogens, we've got 1 chlorine, we've got 1 potassium, we got 1 carbon, and we got 3 oxygens. All right, I generally will leave the H's and the O's for last. Let's take a look at the chlorines. They match. The potassiums don't. So that's where I'm going to start. Always working on the side that is lower. So this 1 is lower than a 2. So I'm going to work on the product side. So I'm going to write something right here so that I can get that K to be a 2. So I want a number that's going to go here that when multiplied by this subscript of 1 is going to give me a 2. So I'm going to put a 2 there. Now, this is what I tell all my kids to do. Scribble out all these numbers. Get rid of them. And recount everything. Because you can make a mistake if you don't. Because sometimes putting a number, a coefficient in, changes more than one thing. So go ahead and recount. We got 2 hydrogens. That didn't change. We've got 2 chlorines now. We've got 2 potassiums now. We've got 1 carbon, and we have 3 oxygens. All right, now let's look at the left side. We've got hydrogens don't match, but I'm leaving those till the end. Chlorine doesn't match, so we can work on those. Carbons match, and oxygens match. So chlorine looks like my winner. So I'm going to put something in front of this chlorine. So there's my chlorine. I got to put something here that when I multiply it by the 1 as the subscript for chlorine, I'm going to end up with this 2. So obviously that's a 2. You're smart. Let's change it so you can see. That's a 2. So I'm going to scribble everything out, and I'm going to recount everything that's on my reactant side. So I've got 2 H's, 2 chlorines, 2 potassiums, 1 carbon, 3 oxygens. Now, because, let's see if I can find a highlighter. Because I left them in order, I could just go 2 and 2 match, 2 and 2 match, 2 and 2, 1 and 1, 3 and 3. And so, therefore, my balanced reaction is 2, 1, 1, 1, 2. That's not good ones, but you get the idea. Okay? All right, kiddo. Hopefully that helped.